Add or subtract. Write the answer in lowest terms. Here we have a subtraction problem. 3 over 2m squared minus 9m minus 5 minus m plus 1 over 2m squared minus m minus 1. In order to subtract these rational expressions, we need a common denominator. Let's begin looking for that common denominator by factoring each of these. Starting with the left-hand side, I'm just going to write this factorization underneath. Our leading terms of our binomials need to be 2m and m in order to get a product of 2m squared. Now, factors of negative 5 that are going to work in here are a plus 1 and minus 5. Checking our inner and outer products, 1m minus 10m gives a negative 9m. And looking at our second denominator and writing it in factored form, our leading terms must be 2m and m. Now we want our factors of negative 1 in the correct spots. If we use a plus 1 and a minus 1, and check, 1m and a negative 2m gives that negative 1m, so that's correct. Now let's determine our lowest common denominator. It's going to contain every factor that we see in here, the greatest number of times it appears in any one denominator. We see a factor of 2m plus 1. It only appears one time in both, so we'll include it one time here. We see a factor of m minus 5. We also see a factor of m minus 1. So our lowest common denominator is the product of these binomials seen. Now let's go back to our difference. We want to build each of these fractions up so that they have that lowest common denominator. So in our first fraction, let's leave those denominators in their factored form for ease. As we compare this denominator to our LCD, we see that it's missing the m minus 1 term. So let's put that in there and multiply both the numerator and denominator by m minus 1. Now as we look at our second fraction, the m plus 1 over 2m plus 1 times m minus 1. Comparing its denominator to the LCD, we see that it is missing the m minus 5 factorization. So let's multiply both the numerator and denominator then by m minus 5. At this point, both of our denominators are the same. So at our next step, let's just write that denominator one time with one long fraction bar. 2m plus 1 times m minus 5 times m minus 1. And let's begin to simplify the numerators. Starting here with multiplication, we get a 3m minus 3. Now be careful with this minus sign. We're going to have to subtract everything that follows it. So I'm going to put a subtraction symbol and then open a parenthesis so I remember to subtract everything that follows. Let's FOIL this numerator, getting m squared, outer product minus 5m, inner product plus 1m gives a minus 4m, and lastly a minus 5. As a next step, let's just recopy that denominator and continue to simplify the numerator. As a next step, I'm going to distribute that minus sign through. So we have a 3m minus 3 minus m squared minus a negative 4m is plus 4m minus a negative 5 is plus 5. Now let's combine like terms in the numerator. And don't forget that denominator. Just continue to rewrite it each time. Combining like terms in the numerator, let's start right here with this negative m squared, the second degree term. Next we have a 3m plus 4m, which is 7m. Lastly, negative 3 plus 5 is a positive 2. Now as a last step, we might look at this and see if that numerator might possibly factor and cancel common factors. But if you think about this, if we began our factoring by grouping method and multiplied -1 times 2 to get a -2, are there any factors of -2 that would sum to 7? No way. So that numerator does not factor. Therefore, we do have a simplest form that is -m squared plus 7m plus 2 over 2m plus 1 times m minus 5 times m minus 1.